transformations, this is how we talk about the movement of graphs. And it's a very good shortcut because it means that we can skip the t-chart, we can skip a lot of that arithmetic, and really just get right to the quick part. So in my last video, we talked about graphing parent functions. And if you really just remember the shape of that graph, you can skip all those steps and we can graph these pretty easily. And all we have to look at is the translation, the slope, and if there's any reflections. All right, so in general, if we have a function that looks kind of like this, f of x, or you could say y, same thing. The k value here, this will tell me what is the vertical translation, up and down, along the y-axis. Or the number here that's being added or subtracted from x inside the parentheses, this would be our horizontal translation. And I said, notice it's the opposite when we have that number inside the parentheses here. It's going to be the opposite of what you think. So if I'm subtracting from x, because this is a minus, remember a minus minus would go in the positive direction. So I'll show you what that means as we do an example, but just it's important to notice this is going to be the opposite direction of what you would think. And then our multiplier out here, whatever number we're multiplying this whole thing by, this would be changing the slope. And if it's negative, a negative slope would reflect it, would flip it upside down. All right, so let's look at just, one or two examples here. So on the first one, I have f of x is equal to 2 radical x minus 4, and then plus 3. So your parent function here, if you can tell, is going to be radical x. So kind of if I strip down all the extra, the 2, the minus 4, the plus 3, if I get rid of all that extra stuff, the most basic, simplest function would just be the square root of x. All right. So if you remember this from my last video, the way that we would graph that is, just starting at 0, 0. There would be a point at 1, 1. There would also be a point at 4, 2. Right, or if you can't remember, you could always do the t-chart also. But it's way easier just to kind of memorize those parent functions. And then we're just going to see what are the transformations here. So the plus 3 is going to move this up 3, 1, 2, 3. The minus 4, remember this is opposite, so I'm not going to go left 4. I'm really going to go right 4. This is going to be the opposite direction of what you would think. So 1, 2, 3, 4. So your new vertex would be right here. The slope would also be 2, so this would be sort of a steeper slope. But for us right now, it really doesn't matter as long as it's not negative. If it's a negative, it would flip upside down. All right, but for us, we can just leave it like that. All right, so that would be, this would be the function here in red. This would be the function, and then I did the parent function here in black, so you can see what the transformations were here. So let's talk about domain and range. So domain is just saying, what are all the possible x values? It looks like our x starts here at 1, 2, 3, 4 right here. And then it's everything bigger than that 4. So I would write that as x is greater than or equal to 4. We don't have any x's that are 3, 2, 1, anything less, anything negative. Has to be bigger than 4. And the range is just saying what are all the possible y values. So kind of the same thing for that. It looks like our y started here at 3, and then it's going up from there. There's no y values that are less than 3. There's nothing that's 2, 1, 0. There's no negatives. So this would be y has to be greater than or equal to 3, which you might also notice are the numbers up here too. But it's definitely easier to tell from the graph. All right. Let me do another one. So this one is a little trickier. F of x is equal to negative 2 times the cube root. So that's going to be our 1, 1, but also negative 1, negative 1. Point here. And then a point there. So the parent function looked kind of like this. Sort of like the square root, right? This was the square root function, but also going in this direction. And then again, for this graph, you just really want to know what is the shape of the graph. Okay, our transformations here, let's do this in green. Our transformations are left 1. Remember, this is opposite inside of these parentheses, or inside of the square root, is going to be left 1. And then up 4. 1, 2, 3, 4. So your new vertex would be right there. All right. This is also a negative slope. So the slope would be 2, a little bit steeper of a slope. But this is going to be negative. So instead of drawing it, like this, it's going to be actually flipped upside down. So more like this. All right. And that's pretty much it. Our domain here, again, all the x values, x goes all the way to the left, it goes all the way to the right. There's no gaps or restrictions or anything. So x is all real numbers. All right, and you could write out all real numbers, or we can use the symbol, which is just an R with a line through it. And same thing for range. There's no restrictions on the range. Y goes all the way up, it goes all the way down. It never stops. So y is also all real numbers. All right. And let's do one more. So let's do this one. So f of x is equal to the absolute value of x minus 2 and then plus 3. So our parent function here is absolute value x. Right? It's just stripping away all these numbers, all these translations. What's the most basic function that you see here in f of x? So if you remember the shape of this, it's kind of like a V shape. Just like that. What are the transformations here? So this is x minus 2. Remember, this is opposite, so I'm going to go plus 2. And then plus 3. 1, 2, 3. Your new vertex would be over here. And then we just sketch the same shape coming out of that vertex, just like this. All right, so for domain and range, domain, no restrictions on x really. You can make x all the way out to the negative, all the way out to the positive, infinity. So x is all real numbers. For y though, y starts at 3. It goes up, but there's no y values down here in the negatives. So it's really just everything from 3 and greater. So I'm going to say y is greater than or equal to 3. All right. So that's pretty much it. Just one more time, this is the important part here. Just if you understand how this works with your parent function. All right. So I hope that helps you out.